Right, so we just completed loading the data, and now we're gonna do some analysis of the data. Let's have a look at what the data looks like. So to have a look at the data, to visualize data, we're gonna do matplotlib, and we're gonna use the library matplotlib, and we're gonna load it as PLT. It's just easier to work with. Now we're gonna make a scatter plot. I remember what I said. The first 50 rows are Setosa, and then essentially we're looking at data 50 to 100 is versicolor, and the final 50 is iris virginica. And that's all we're doing here. And we're looking at 0. So we're looking at column 0 and column 1, if you remember. So column 0 is sepal length. That's how Python works. It goes 0, 1, 2, 3, 4. So technically, if we're looking at this, so I might do this interchangeable, but just keep it in your mind, because that one has got me before. That's got me before. I was getting confused. I forget what the situation was, but I got a bit confused about that. So just remember, we have here, we're looking at 5 columns. In everyday life, you're looking at 5 columns, but in Python, we have 4 columns. We still have five. You still have five, but it goes 0. It starts counting from 0, essentially. 0, 1, 2, 3, 4, right? So just keep that in mind. I'll try to stick as best I can to just normal speech, which is 1, 2, 3, 4, 5, but I'll make sure to make that clear as possible. But if you ever find yourself getting confused, just remember that it's 0, okay? Enough of that. So here, essentially, this is where we have to go to Python speech, which is we're looking at column 0, which is sepal length, and we're looking at column 1, which is sepal width, and we're doing a scatter plot against that for Setosa, versicolor, and virginica. So here we have sepal width and sepal length. So column 0, column 1 for all the different species, and we can see that there seems, what I noticed from looking at this is that there is a strong correlation when it comes to Setosa. There's a strong correlation between sepal length and sepal width. So essentially, I'm saying that once the sepal length is large in Setosa, it tends to be large in the sepal width tends to be greater in in Setosa. There's a correlation, a positive correlation. This goes up, that goes up. It's the correlation is not as strong when it comes to the other two species, which is interesting. We might be able to classify the species based on this. And just to go more into this, because I don't want to fly through this too quickly, the rest of it isn't that important. It's just labeling, and I'm pretty sure you should be able to decipher this. Font size, you can play around with that and just see which one suits you best, which one you prefer. And so it's fairly straightforward, this PLT. So this is the data, and then we're taking the first 50, then the next 50, then the last 50, so that we have the right species, because it goes the first 50 Setosa, second 50, and so on and so forth. We're doing that for here. We're doing it for the sepal width, and then here we have to do the same for the sepal length in order to make the scatter plot. So yep, finish there, and then we're gonna do it. We're gonna take the number 2, which we're looking at the petal now. So petal length and petal width. And for all species, it's essentially the same thing as above, except we're changing the columns we're looking at for each of the species. And now we can see that there's a way stronger correlation. So there's a way stronger correlation with the petal width and petal length, and we're going to see this in a heat map. So a heat map is a nice way of viewing correlation. The lighter the color, the greater the correlation. The darker, the not so good the correlation. So based on this and what we've seen above, we can determine that if I see petal width and petal length, we're gonna have a high correlation between these columns. And so let's go to petal. So petal length and petal width, 0.96. Best correlation is 1. So very close to 100% correlation, which is 1. And then we have, then you can look at, if you look at sepal width and sepal length, for example, sepal width, sepal length, not as good. Sepal width and sepal length, very, yes, very, very low. Sepal width, sepal length. This is taking into account, all the species now. We noticed that there wasn't really correlation between Iris versicolor and virginica. But although we did have great correlation in Setosa, but overall, not great correlation. Even in that, in just normal predictions, more much more simpler prediction, you can base off the length. For example, we can nearly say in this case, this is the good thing about analysis. We haven't even done the machine learn. We haven't used the machine learning model, but from looking at this data here, we can say that if we see a species that has a petal length in the range between 3 and a petal width in the range of 1, like within this square. I can't put a square in, but within this square, we can say it's likely that that species is a Setosa without using machine learning model for help. So that's a nice thing to keep in mind. Done the heat map, and now we get to pre-processing, which is the next step